Welcome to James Maths Academy. So let's solve this little problem on integral. Okay, so if you have something like this, how can you solve it? If you notice, the first function is raised to power 5, while the other one is raised to power 3. So this can also be written as this. I can also write it like this. This is sine 5 raised to power x cos um, cos square x cos x dx. Okay. So there are different ways of solving it. If you go to a different textbook, they have their own method of solving it. But this is actually the easiest way in which you can solve it. So the next thing you can do is to refer to our trig identity. So for our trig identity, we know that cos square x plus sine square x is equal to what? 1. Okay. So what we're going to do is that we're going to substitute s square. You're going to make this s cos s square as what as the subject, and if you are going to make it as subject, you're going to have cos square x is equal to 1 minus sine square x. Good. So since we have this type of equation, it means that whenever you see s cos s square, represent with what? 1 minus sine s 1 minus sine minus square x, isn't it? So let's recall to our initial problem. So we have our integral sine raised to power 5 s. This cos square x there with what? 1 minus sine s sine square x. So it's going to be 1 minus sine square x close bracket cos s dx. Wow. So if you notice, this cos s square have been replaced with this 1 minus sine square x. So everything is working perfectly. So the only thing you can do is to multiply these terms together, okay, since they are the same term. So you're going to can also be written as this multiplied by 1 is going to you see remain itself. This is minus sine 5 sine raised to power 5 x times sine square x is going to have sine 7x. Okay, let me bracket it because everything must be multiplied by what? Cos s dx. So we want to replace this dx so that because I want to cancel this cos s. So I'm going to replace this ds. So if I'm going to do that, it's going to be u is equal to sine x, and du dx is equal to what? Cos x. Okay, so if you are to make the x the subject of formula, you're going to have du over what? Cos x. Okay, so since we've gotten this, we are arriving to somewhere. So what we're going to do is this: we're going to refer to this initial problem. So let me clean this side. Let me clean this side from let me clean this. Let's recall back. We know that our u, anytime you see u, we are told to replace with the sign x. So you're going to have our integral. I'm going straight to what we have. This is u raised to power 5 minus u raised to power 7 cos s cos this s, and the x. Anytime you see the s, replace with the u over what? Over cos s. So you're going to have by du over what? Cos x. So this cancel this. Okay, so essentially we're going to have you can open the brackets or you can leave it. You can also open the bracket. You can replace as u raised to power 5 minus u raised to power 7 du. Okay, so if you have to differentiate all of them, you're going to if you have to differentiate the u raised to power 5 du, you're essentially going to have, because this can also be written as u raised to the power 5 du minus integral u raised to the power 7 du. Okay, so if we integrate u raised to the power 5 du, we're going to have u6 over 6 minus, if I integrate this, we're going to have u8 over what? 8 plus c. Okay, definitely our u is what? Sin x. So let me clean this side. So you're going to have sine 6s over 6 minus sine 8x over 8 plus c. So this is our final answer to the question. Okay, so the first thing first is to use to understand the problem. Okay, once you understand the problem, you know how to solve it. So once you know that you can use a trick identity, you understand. Once you can know how to make use of trick identity, just refer to it. With much passes, you'll be able to understand how it works, and I also employ you to do more practice for you to understand the concept. Okay, so for more informative content, don't forget to like, share, and follow my channel, James Maths Academy. Until see you next time, thank you.